Hello students, we are going to look at this three-dimensional trigonometry question from your packet. Number 1, we have a cuboid with the side lengths 5, 6 and 10 centimeter. So just to make it easy for us to imagine, I'm going to use GeoGebra. So first we are asked to find the length of AC. So AC is just here, this segment on the kind of like base of this cuboid. So when we look at this cuboid and we see AC there, you can easily understand that when I just look at it from this angle, the base of this cuboid is just a rectangle, and then AC is basically just the hypotenuse of this triangle. All right. So, and of course we have a 90 degrees angle here because it's a rectangle. So then if we have 5 and 6 as the length of the two right angled sides, we can just easily use Pythagoras theorem and calculate the square root of, so 5 squared at 6 squared, and then the answer is 7.81. so then for AC the answer is 7.81 centimeter. All right, so now we are asked to find the length of AG. So I'm going to try and make a kind of segment AG there. So if I try and connect A and G, this is what we have. And then if I just try and make it clearer from this angle, you can see that ACG is just a right angle triangle as well, and the right angle is actually located at C because this one is vertical from the base, and the base here, this line AC, is actually horizontal on the base of this cuboid, right? So we can again apply the Pythagoras theorem, and we will use AC and CG now as A and B for the Pythagoras formula. So go on and calculate again with your calculator. We already have AC, which is this long answer. We can use 7.81, but it's probably more accurate to use this long version. So I'm just going to say we will take the square root of this number squared, and at the side CG is 10 squared. So with this handy calculator, it's actually very easy, right? So then you have answer is 12.6888 and so on. So to 3 significant figure, that's going to be 12.7 centimeter. Okay, so now we are asked to find angle GAC. So let's go back to our app here. Angle GAC, which is here. So because it's a right angle triangle, of course you can use SOHCAHTOA, and we have side CG, and we also have side AC. So let's go back and calculate. We can use actually from here tangent. Well, and because we actually know AG as well, you can basically use anything. You can use you can use cosine or sine. But in this case, I'm just going to try and use tangent. So then side GC is 10 and AC was this long number here, right? So then we are going to say shift 10, and then opposite of the angle, which is 10, and divided by the adjacent, which is side AC, which was this number here. Okay, and then when we press enter, 0.99, that doesn't seem right. So you know what it is. What happens is you go to setting, and make sure that your angle measure is in degree mode. So let's go back then and do this process one more time. And when we say enter, we get 52.009 and whatever degrees. So I will put the answer here, 52 to the nearest degree, 52 degrees. Oh, let's see what happens to my so that was 52 and degrees. Okay, so and then you are asked to find angle between AG and plane ABCD. So AG is this one, this line, and plane ABCD is just here at the bottom. So basically when you are asked that, you can just imagine that you put a light here somewhere and shines it like upright. So the shadow of AG, its projection on the base will be line or segment AC, right? So the angle between AG and the base will be actually the angle between AG and AC. So which is angle GAC, which we already have figured out before. So it will be the same answer, 52 degrees. Okay, I hope this makes sense. So good luck there.